My pranams to all of you. It's indeed an honor to be addressing this August gathering where such luminaries have been speaking. I'm grateful to Professor Gopinath and the founders and promoters of Plaksha University. So I will try to just indicate what I understand by the methodology and try to show that there is some flavor of Indian way of doing science, and I will try to indicate that flavor from a brief look at the texts of science themselves. So this shastra means a systematic instruction, but the shastra texts of India are somewhat very different from the texts, say Euclid's geometry or Newton's Principia or Paul Dirac's quantum mechanics. They are not a collection of axioms or theorems or ultimate truths. They actually give some detailed procedures, or in Gopinath's language, algorithms. And they are called actually in our text vidhi, kriya, prakriya, sadhana, karma, parikarma. These are the words used. In fact, the famous quotation of Bhagavad Gita that shastra vidhi is what Bhagavan Shri Krishna is emphasizing. So basically each shastra defines a purpose. It limits itself. It doesn't say I'm going to tell you everything. So the Vyākaraṇa people say, we are going to tell you how to derive valid words and sentences. That is Shabdanushasana. So mathematicians will say, we will tell you how to calculate with numbers and figures and things like that. Or the astronomers actually call themselves as Kala Vidhana Shastra, how to measure time or determine time. And time includes place and direction. And how to determine it by looking at the motion of celestial bodies. The Ayurvedic physicians characterize their discipline as amelioration of diseases of the sick and protection of healthy. So they sort of limit their purpose, and then they give various procedures as to how various objectives in this limited purpose can be carried out. So in that sense, having defined a very limited area, they can think of multiple ways. They need not be very dogmatic about how things are done. So how to do this? So all shastras say, or it's a popular saying amongst Indian texts and scholars, that these Kanada and Paniniya shastras are basic for knowing all shastras. Kanada means the Vaisheshika of Kanada Rishi, and also the epistemology, the ontology or metaphysics of Vaisheshika, and the epistemology of Nyāya. And why Paniniya? Because, of course, language is very important, but the technique that Panini used for specifying huge numbers of procedures by a very small number of 4,000 rules, the procedures for deriving all possible valid words and sentences are contained through those 4,000 rules. So those techniques that he used are indeed very primary. So if you go later on in Shrauta Sutras or things like that, it has been pointed out all this Paninian kind of methodology is seen there. Perhaps they are prior to Panini even. Okay, now what is this epistemology? Meaning what do Indians understand as knowledge, true knowledge, how it is acquired, how it is validated. And so that is a basic topic of all Indian schools of philosophy. But the school of Nyāya is something which goes into this issue in much greater detail than the other schools. So they have these four pramanas: pratyaksha, observing things; anumana, doing inference, argument; upamana, analogy; and shabda is traditional text or even the testimony of some other scholar that you know. But the crucial thing, these are of course very well known. We use them even today in all our ordinary activities and of course in our systematic study like sciences, etc. But what the Indian text says, there is a hierarchy amongst them. So this is one of the crucial facts of Indian way of understanding what is valid knowledge. So this hierarchy is that this pratyaksha is at the pinnacle. And then comes Shabda or testimony, which has been the pratyaksha of either the ancients or the other scholars. And then comes Anumana, which is what we normally know as inference or reasoning. And most of inference or reasoning for Indians was what is the scientific inference, inductive inference. And so the Nyāya Sutra, Vatsayana's commentary, itself says, Pratyaksha Agama Aviruddham Anumanam. So Anumana, which is not contradicted by Pratyaksha or by the textual tradition, that is the valid Anumana. So this is the principle. And our scientific texts very closely follow that. This is a quotation from Sushruta Samhita, where he is saying even thousands of arguments will not make a group of drugs called ambashta cause purgation. So sahasranyapi hetunam na ambashtarihi virechayet. And this is another quotation that pratyaksha overrides any textual authority. That was pratyaksha overrides anumana. This is pratyaksha overrides textual authority. This is Shangadhara Samhita, 13th century text. So which is saying that if a physician has observed that certain class of herbs are not effective in some disease, even if the text says so, he will have to abandon them. Because there's something that has. So this is even said even in Adi Shankara's Brahma Sutra Bhashya, Bhamati, Sahasranyapi hetuni ghatam pataitum na shaknavanti. So, even thousands of statements in Agama will not make a ghata into a pata or something like that. So, this is a very valid and accepted hierarchy of these pramanas, which is very characteristic. I mean, while doing science, we are always keeping this in mind as to what is the hierarchy of valid methods of knowledge. So, this is Nyāya theory of inference, which is basically sort of inferring fire from smoke, which is an inductive inference, and it is based upon a certain generalization that wherever there is smoke, there is fire. And this statement, to analyze it, to understand it, is a very major thing of the Nyāya tradition. And so in some sense, much of the inference theory in Nyāya is like argumentation in empirical sciences. There is one thing which is very peculiar about Nyāya, that it does not want to include in an argument, even for the sake of argument, a hypothesis which is known not to be true. So a counterfactual argument is not accepted as a valid argument in Nyāya. So this is very common, especially in mathematics. About 90% of proofs from Euclid's book onwards use a method called reductio ad absurdum, that you assume the contrary to what you want to prove and show a contradiction, and then. So how this affects Indian mathematics, I will indicate a bit later. So basically this kind of an argument is called tarka, and this is very useful in Nyāya. Tarka is used to make an inductive inference more precise. But the tarka is not used as a pramana in itself. So tarkaha na pramana sangrahitaha, it is not included amongst the pramanas. Na pramanantaram, it's not an independent pramana. Pramananam anugrahakaha. So it can be used to make an inference more precise. So now I come to one of the pinnacles of Indian sciences, Ashtadhyayi. All of you know that the basic purpose of Ashtadhyayi is written in amongst all the commentators, that using Prakriti and Pratyaya, that is the Pratipadika and various things that you add to it, you derive all valid words. And the Ashtadhyayi is supposed to be a complete systematic set of rules to do that. And as you all know, there are 4,000 sutras of Panini. Along with it, there is this Shiva Sutras, which gives you how to group sounds into various subsets. It's the sort of symbolism that is very essential. The Dhatu Pada, which has about 2,000 dhatus, from which all words have to be ultimately derived. Then there is a list of 261 list of items, because these are words which are already done. They do not come under Panini's rule of derivation. It's called the Ganapata. Apart from that, Linganushasana, Unadi Sutra, etc. The basic thing is, using this entire system, Panini proposes to derive, or the followers of Panini proposed to derive all this. And actually this has been found to be very successful. Of course, the commentators of Panini, starting from Vartika, then Mahabhashya, then Kashika, and various further developments, they improved upon the system. Wherever it was not working, they have corrected it. And so the modern understanding is it's the most complete generative grammar of any language yet written. Another thing is that many of the developments in modern linguistics from 19th century onwards, first in phonetics, then in morphological analysis, then in generative syntax, have followed from the study of Ashtadhyayi. And if they appear similar, Kipasky says that's because they have been borrowed from Panini. But now what is our grammarian's understanding of Panini's grammar? So it's such a perfect grammar, but they do not want to say this is the last word in grammatical analysis. So here is Bhartrhari in 5th century. He is saying, while discussing Paninian grammar, that it is only an upaya. It's only an instrument, a means to derive correct words. And upayanancha niyamaha na avashyam avatisthate. There is no limitation on the kind of means that you need to employ, as long as it gives you the desired result. I mean, in shastra, not in practical life or the world. So, and so the commentator says one teacher may use Paninian grammar, another teacher may use, there was Katantra, Aindra, and various other systems of grammar. They're actually not as good as Panini's grammar. But in principle, the commentator is saying if they work well, there is no objection. So, in philosophical dispute or discussion, Indians were not willing to say Panini's grammar is the last word, or it's universal, it is applicable for all times. That kind of a statement you never find in the texts themselves. So going to mathematics. So mathematics is defined as Sankhyaete, Ganyate, Sankhyaete. It is science of counting, science of calculation or computation, whatever you may call. And in fact the word algorithm itself has a very strange history. It's actually the distortion of the name of Al-Khwarizmi, a Central Asian, Uzbekistan I think he was from, as an astronomer and mathematician, who made the West Asian world or the Islamic civilization aware of the Indian methods of calculation. As you know, from Aryabhatiya onwards, the kind of methods of multiplication, division, square root, cube root, are all systematized there. That's what made calculation extremely simple and popular and universal. And that was made known to the West Asia. Even earlier, a Bishop Sever Sebokat talks of Indian methods of calculation in 7th century. But anyway, Khwarizmi wrote a very systematic book. The original Arabic work, Hisab al-Hindi, is not available. Its Latin versions are available. So there it starts with Dixit algorithmi. And from that the word algorithm. Algorithm means a systematic method for carrying any procedure. And that comes from the spectacular methods of calculations used in India. Now there was this criticism whole of 19th century that Indians discovered a lot of mathematics but did not write proofs, etc., etc. All the Western scholars, whenever they talked about Indians, they said they lack logical rigor, they have imagination, etc., etc. And in comparison to the Greek mathematical tradition, this was said repeatedly. Even a book written in 2000 or 2010 may happen to repeat the same thing from other books. But the way Indians understood justification in mathematics, that was called Upapatti or Yukti. So here is Bhaskaracharya talking of what Upapatti is supposed to do. Basically, Upapatti is supposed to do is to make a mathematician feel honored or feel accepted in a community of mathematicians. Praudhim, praudha sabhasu, naiti ganako, na nitsamshayo na swayam, upapattim vina. If you do not provide proof for what you are suggesting, then you will not be considered a good mathematician amongst the community of mathematicians. Another is, when questions are asked, you will not be free of doubts. So these were the criteria that a proof had to satisfy. The crucial thing there is no statement saying a proof is something, after all we write quod errand demonstrandum below every proof, that it is supposed to provide an irrefutable justification of the absolute truth of the statement that you are making. So such a claim was not the ideal of Indians, even in mathematics. And that's because mathematics was also thought of as much like empirical sciences. And its results do derive from our understanding of natural phenomena. But there was an understanding that mathematical results are those which can be justified and argued about without recourse to an old textbook, that we can in principle argue about those results. So these kind of extraordinarily difficult infinite series were proved in Kerala mathematics in around 1375. Many of them, as I have indicated, were rediscovered later. And here is Ramanujan. Oh, it won't show. And this is a series that he wrote down in 1910 and I think published in 1914. For the first time, billion digits of pi were calculated in 1980 based upon this. So this tradition goes back from Madhava too. So the difference between Indian understanding of proof and the Greco-modern European understanding of proof, the rigor of modern Western understanding of proof and the Greek understanding of proof actually prevailed historically in mathematics only for a short windows. So between Euclid to Apollonius, a period of 250 years, including Archimedes, that is when Greeks proved all the results in that rigorous manner. And afterwards, there was long gap, and the much of development of modern mathematics in Europe was, as historians call it, it's a sort of a celebration of leaving the canon, Greek canon to itself, celebration of innovation and imagination. Whatever Leibniz, Newton, Descartes, Fermat, all of them did. Fermat was well known for writing, I know the proof of this, but this margin is too short for me to write it. So, but that kind of proofs arose in Europe in 19th century with set theory, with Weierstrass and Dedekind and mathematical logic, Cantor and Russell and all that, and the paradoxes and various problems. Okay, Indians didn't go through all that. So in Indian tradition, mathematical knowledge is taken similar to empirical knowledge. Indian mathematicians are very clear that mathematical results are not to be claimed by merely saying 10 instances, 20 instances, or even large number of, unlimited number of instances. This is satisfied. They have to give an argument. They have to give a yukti or an argument. And but the purpose of Upapatti was to mainly remove doubts and obtain consent. And there was this deductive sequence from known results to unknown results. So if you read texts like where Madhava's results are all proved, a text called Yukti Bhasha written in Malayalam in 1530, it goes very systematically from known to unknown even to derive very complicated results. And it uses things like this, what is called mathematical induction and all that. And the one thing which is very important in Indian mathematics is that they refuse to rely upon this reductio ad absurdum. They do use reductio ad absurdum, that is, if something, non-existence of something is to be shown, they show that if you assume that it existed, you get a contradiction. But to prove the existence of something using reductio ad absurdum is not to be seen in Indian books. That is, you have some differential equation and you want to prove its existence of its solution, then you have to find a method of solving the differential equation. Merely showing that non-existence of solution to that differential equation contradicts what you know. This does not satisfy an Indian mathematician. So in today's mathematical philosophy, this is called the constructivist approach to mathematical knowledge. Okay, finally a few words on astronomy. So the astronomers were very keen to have not merely a good method of calculation, but their calculations had to conform with observations. One of the oldest quotations is from this book Professor Iyengar has been talking about and is publishing, this Rudagarga Samhita, Darshanam, Gaṇitam Chaiva, Yugapat, Yoga Sadhakam. So that mathematics and the observation have to be together. But even if your mathematics and observation is together, there were various planetary models starting from Aryabhatiya. The first commentator or first available commentary on Aryabhatiya due to one Bhaskara, the older Bhaskara, while discussing the planetary model of Bhaskaracharya, of Aryabhatta, he is saying that these planetary models are only sort of upayas. They are again the means to calculate the positions of planet. You should not confuse them with what is Einstein's language, elements of reality. So these concepts that you use in astronomy, Ucha, Nicha, that is upsides, Madhyama, mean planet, Paridhi, the radius of the epicycle, evam ityadi sphutagati sadhana upaya bhutanancha upayanam naiva niyamaha uktihi va vidyati. There is no limitation on that. And then he says, it's similarly so in Vyākaraṇa also. We use all these notions called Shabdikaha, that is grammarians, Prakriti, Pratyaya, Vikara, Agama, Varna, Lopa, Vyatyayadibhi, Shabdan Pratijanite. There also, this is just our aid to understanding words. These are not ultimately truths about the languages. So in the same way, Upayeshu, Asatyeshu, Satya Pratipadana Pareshu, na Chodyamasti. We should not be startled by the fact that the Upayas may not be really real, but they are giving us some indication of the reality as such. And Nilakanta Somyaji, in 1500, he came up with a revision of the traditional planetary model of India, and he sort of discovered from arguments and observation that Mercury and Venus go around the sun and do not go around the earth. In fact, the very simple argument is that something called longitude, that is the way the planet is observed close to a star when it moves around as seen from the earth. Something called latitude, that is you have the plane in which the earth goes around the sun or sun goes around the earth. The way planet goes up and above and below that plane, that is called the latitude. So the Mercury's period of 84 days, it's a period in which it goes around the sun. So its plane is inclined to the plane of Earth's orbit. So its latitude completes one full cycle in 84 days. But it is seen going around all the stars along with the sun in 365 days. So from that he sort of concluded all planets are going around the sun. Now here is Nilakanta Somyaji talking about this famous work of him called Jyotiṣa, where he is answering a very important question. Professor Iyengar keeps saying that in India we ask questions all the time and not come up with the final answer. So he's sort of telling. Now everybody may argue that Aryabhatta discovered all this great planetary model because he did great tapas, and Brahma being pleased with him, he was pleased to grant him the true knowledge of planetary motion. And therefore the planetary model of Aryabhatta cannot be touched or modified by us because this is divine revelation. So he says, if you think so, you are being an idiot. This is not true. Devata prasado mativarimanya hetureva. The grace of Brahma is to clarify your intellect. And he says, even Aryabhatta in his own, Aryabhatiya writes, in fact one of the last verses of Aryabhatiya is, Sadasa Jnana Samudrat, Samudritam, Sadasa Jnana Samudrat, Samudritam, Devata prasadena, Sadjnanottama Ratnam, Maya Nimattam, Swamatina. I have taken out this Ratna of true knowledge from the Asat Jnana Samudra, from the ocean of true and non-true knowledge, by Devata Prasada and by Swamatinava, by my intellect, or you can mix it and say Swamatinava, by the ship of my intellect also. Anyway, and another thing he said that the older theories were perhaps correct in those times, and if they are not in conformity with observations, you should not hesitate to reformulate them. And in fact, what you should teach the students is the method to test a theory, that is called pariksha. The text, the purpose of instruction is to teach pariksha, and that's what makes the student. So basically, this is the way Indian sciences, they text themselves. What they say is, our knowledge, especially in the material world, is fairly contingent, and we have to be continuously concerned about the change of situation. So the Siddhantic astronomers did not talk about Dhruva because they knew that Dhruva was no longer with the Abhaya Dhruva, with the older Shishumara constellation, and there was no star in the position of celestial pole. It's only in the last 300, 400 years, this Alpha Minoris, Ursa Minoris, the current pole star is seen. And so Kamalakara and others have been talking about it, so that this continuous change is accepted. But what perhaps we need to have realized while integrating, many times it's said that we integrate Indian knowledge with the modern knowledge. What we have to understand is that we can integrate knowledge but not philosophies. So the Greco-European thought is known for insisting on absolute truth of their findings. Especially Plato said mathematics is the ultimate knowledge of the divinity. And this continued, and the modern science, Needham and various other scholars have shown at the time of emergence of modern science in 16th, 17th century, most scholars talked as if they were trying to understand the creator's mind in putting these great exact laws at the time of creation. So this even the idea that science is these laws of science, the universal laws of science, it's as if like a king commanding the nature to perform. So this idea you will not find, this especially a peculiarly idea of Western civilization. The Chinese didn't have it. And so, I mean, I have nothing against laws of nature, but their limitations that the Indians all the time emphasized have to be, I mean, if we want to keep using that word. So it's things like this, and even the other idea that much of creation is for the sake of humans. These are ideas that we do not find in our scientific or technological tradition. So when we integrate things, we have to be very careful in integrating. And thank you very much.